So last time we had talked, we had spent some time talking about solving right triangles, like a little bit of review from geometry that we would have done in the past. And then we talked about what to do in an instance where we don't have a right triangle, like, okay, because we've lost the tools that we would have used for a right triangle. And we introduced these two new tools that we have access to called the law of sines and law of cosines that are available to use in a situation where you don't have a right triangle. And we talked about, okay, when I'm solving a right triangle, it's pretty obvious when I want to use the Pythagorean theorem or when I want to use SOHCAHTOA, because, well, if I have an angle, I got to use SOHCAHTOA, and if I don't have any angles, I got to use the Pythagorean theorem. It's pretty straightforward. But in the case of the law of sines and law of cosines, both of them need sides and angles. So we talked a little bit about what kind of instances that we would use one versus the other. So for the law of sines, we said, okay, when we're given like an angle or angle side angle or angle side or side angle situation, we're going to use the law of sines. And if we have a side angle side or a side situation, we'll use the law of cosines. And we went through and looked at specifically like, okay, what does it look like if I have an angle side angle or an angle side? Like, what's the difference between these ones and that? And went through some examples of all those. And then I think we did one example in a angle side angle situation using the law of sines to solve. So today we're going to pick up where we left off. We're going to do some more examples of these other situations. There's two of these specifically, the side angle and the side where there's a little bit more to it than that we'll kind of go through carefully and make sure that we talk about like, okay, what's this additional complication going on in these situations, and what are some of kind of the rules that we need to make sure we're following when using those or when we run into those situations. Okay? All right. Okay, so let's say we have a triangle with angle Q 43 degrees. I'm sorry, angle P 43 degrees, angle Q 80 degrees, and side Q 7.3 centimeters. The first thing that I would do is I would draw and label a picture. So when I label the vertices, obviously one of them's P, the other has to be Q, and the third one, what would I want to name the third one? I'd use R, not because I'm a pirate, but because the alphabet. And then remember, when we name the sides now, we're going to name these in a very specific way, right? So the side opposite angle P, I'm going to call side P. The side opposite angle Q, I'm going to call side Q. And the side opposite angle R, I'm going to call side R. And then I'll write in these other known values here. Okay. So which situation am I in? And I have two angles and a side. Is this angle side angle or angle side? This is angle, angle, side. Again, remember you can tell because the side that's given is not part of both angles, right? That's what we're looking for angle side or angle, angle, side. Is that given side is not a part of both angles. Okay. So we're going to need to find angle R. We're going to need to find side P. And we're going to need to find side R. The order in which we do this doesn't really matter. But one of these is super easy to find. Let's find that one first. What's the one that's super easy to find? Angle R, right? How do I find angle R?
Add up the other two, subtract that from 180.
Exactly right. So I can add up the other two and subtract that from 180. So that's got to be 57 degrees. Everybody cool so far? Okay, that leads just P and R. So we need to use the law of sines. To use the law of sines, I want to start by finding the angle and side that I know both of. So do I know angle P and side P, angle Q and side Q, or angle R and side R? I know Q. Great. So I'm going to start by writing sine Q over Q is equal to. Now, does it matter which one I solve for next? No, not really. So let's pick. We'll pick P. So I'll do sine of P over P. So that's my equation. Everybody happy there? To solve this equation for P, I'm going to cross multiply. So that gives me P times sine 80 equals 7.3 times sine 43. And then we'll divide both sides by sine 80. And now it's calculator time. When I go to type this into my calculator, what do I have to be careful about? My mode. What mode should my calculator be in? Degrees. How do I know that? Because the angle measures are given as degrees. Very good. Now I already know that my calculator's in degree because we did this already. So I get 506. And I guess the unit there was centimeters. Okay. So now I know two side lengths, so I can just use the Pythagorean theorem to find the third one, right? No, good. Why not? Not a right triangle. What do I do instead? Same thing, right? So I'm going to just do sine Q over Q equals sine R over R, and we'll just do the same algebra that we did before. So we'll cross multiply. And divide by sine 80. And then it's calculator time again. Oops. So I get 6.22. Everybody feel okay on that? Good. The next thing that I want to talk about is this SSA situation then. This is sometimes called the ambiguous case. So if we go back and we think back to our geometry class, I know that was a long time ago. If you think about your triangle congruence theorems, it also had those 3 name abbreviations. So like here, we had 5 of those 3-letter abbreviations for the law of sines and law of cosines, right? We had angle, side, angle, angle, side, angle, side, side, and side, angle. Of those 5, one of them doesn't fit when we think back to geometry and those triangle congruence theorems. It was the side, angle situation. That is not a triangle congruence theorem because, well, it turns out that you can have 2 triangles that have side angle congruence, but do not have triangle congruence. So let's just kind of demonstrate that here. Oops, that's too big. So all I'm going to do here is just kind of construct a situation like that. So you guys can see what I'm going to do is I'm going to draw 2 triangles that have side lengths 10, 12, and then a 48-degree angle, and show you that I can make 2 distinct triangles that both have that same information. Okay. Again, this is just me demonstrating for you guys. So I said 48-degree angle, I think. Do that. Now I'm going to just put a line through here because that 10 unit or that length 10 side, I'm going to connect back to this line somewhere to make my triangles. To do that, what I'm going to do is I'm going to make a circle with radius 10. Notice that circle intersects that other side at 2 separate places. So I can make the triangle CAB. And notice that triangle is 10, 12, 48. You guys all see that? If I make the triangle DAB, I also have side lengths 10, 12, and then at a 48-degree angle. You guys see that? How I can make 2 triangles with those measurements? Now, in your geometry class, there was one specific situation where side angle does hold. And it's that when this angle B is a right angle, so if this was a right angle, then side angle does hold. Your textbook, I think, has a name for this theorem or this situation. They call it the Hypotenuse Leg Theorem. Not that I would expect you in any way, shape, or form to remember that name, but if I say it and you're like, oh yeah, that sounds like a thing, that's fine. So this side angle situation is very tricky because as this angle B gets bigger, these 2 separate lines that make our 2 separate triangles are going to get closer and closer together until they become a single line where we have only one triangle possible. And then as it gets bigger, it would turn out that that circle wouldn't even intersect that other side and no triangle would be possible. So in this side angle situation, we have to be quite careful because it turns out that if I just give you, any 2 side lengths and an angle measure, sometimes you could have 0 triangles possible, like it's an impossible problem. Sometimes 1 triangle might be possible. And sometimes 2 triangles might be possible, so we'd end up with 2 sets of answers. So let's kind of walk through the criteria, or how we would go about figuring that out. Okay? So there's 3 cases. Case 1 would be where angle A, let's draw a picture here because I want to use some. Let's start with this. Okay. So let's say, for the sake of argument, because I'm going to use some letters in abbreviating this, let's say that here is our triangle ABC. And let's say that we're given the angle A and then the sides AB and BC. Okay with that? All right. So now we'll say we have 3 cases. Where the first case is where angle A is obtuse. When I say obtuse, what does that mean? Greater than 90 and less than 180. Right? So if angle A is obtuse, then the relationship between the sides AB and BC could be 3 different things, right? AB could be, let me make sure I do this in the same order I write down here. So if anybody goes back to look at this, okay. So let's say BC is greater than AB. Or BC could equal AB, or BC could be less than AB. Right? Those are the 3 relationships the 2 side lengths could have. Now, if I look at my triangle here, if angle A is obtuse, I know that angle A has to be the biggest angle then, right? Because I know a triangle can't have 2 obtuse angles. Everybody agree with that? Since there's only 180 degrees in the triangle, if you have 2 angles bigger than 90 degrees, well, you don't have a triangle anymore. So if angle A is the biggest angle, what can we say about the side BC? It has to be the longest side, right? So here, if BC is bigger than AB, that's okay. We'll just form one triangle in that case. However, if BC and AB are equal, BC can't be the longest side now if they're equal, in which case that means this triangle would be impossible to make. So there's just no triangle possible. And obviously the same thing if BC is smaller than AB, right? So that's kind of common sense. If angle A is the biggest angle, that means BC would have to be the hypotenuse, and if it's not the longest side, then it can't be the hypotenuse, and no triangle is possible. Okay. What if angle A is 90 degrees? What can we say about that? Is angle A still the biggest angle? Yeah, guaranteed, right? Can you have 2 90-degree angles in a triangle? Nope. Can you have a 90-degree and obtuse angle in a triangle? Nope. So the 90-degree angle still has to be the biggest angle, right? Everybody agree? So what does that mean about BC? Still has to be the biggest side, right? So the same thing that we had in case 1 is still going to be the same thing we have in case 2. And so far, this SSA situation, not that big of a deal, right? Well, the tricky part here is when angle A is acute. Okay. So when BC is bigger than AB, that's good. Only one way to make a triangle there. when BC is equal to AB. That's good. There's only one way we can make a triangle there. But when BC is less than AB, this is when all heck breaks loose. Because we can have 0 triangles, 1 triangle, or 2 triangles. Ugh. Now, the natural question there would be what to do to figure out, well, which one is it, 0, 1, or 2, right? Everything else, it's, okay, I just need to compare the angle on the two sides, or look at the angle and then compare the size of the two sides. And it's real straightforward. But here it's not so easy. Doing that doesn't tell me whether I should be looking for, whether the problem's possible or not. So how do I tell the difference? Well, here's what we're going to do. We're basically going to be using the law of sines again. So if I look, angle A and side BC are opposite each other. So that would make up a ratio for the law of sines. I know side AB, so that means I'd be using angle C with it, right? Is everybody okay with that? So I'm going to set up that law of sines problem. I'm going to say sine A over BC equals sine C over AB. And the piece that I don't know is this sine C, right? Or is the C in the sine C, I guess I should say. So we'll cross multiply. So BC times sine C equals AB times sine A. And if we divide both sides by BC, we have this. And whatever that number comes out to be is going to tell me whether I'm going to have 0, 1, or 2 triangles. If that number is bigger than 1, I get 0 triangles. If it's equal to exactly 1, I get 1 triangle. If it's less than 1, I get 2 triangles. Of course. Now, the other way to think about this formula that I've just written is if we're in this specific SSA situation, that formula AB times sine A over BC is kind of a pain in the butt to remember. The way I remember it is just longer side times sine of the given angle divided by shorter side. That to me is a little bit more instructive than like having to draw and possibly relabel my triangle because the letters would be different in a problem than the letters that we chose here. You know what I mean? All right. So let's do a couple of numeric examples here to make sure that we kind of got the hang of this, because it's, not the easiest thing in the world. Okay. So let's say we want to solve the triangle where angle P is 56, side P is 16, and side Q is 19. Well, if we have a side Q, we must have had an angle Q. And then I guess I need to pick a name for my other angle. I'm going to pick R because, well, the alphabet. So again, we'll name our other sides in that fashion that we described earlier. So if I go in and add in my labels, what do we notice here? What situation are we in? That's what I'm asking. Yeah. This is the SSA situation, right? Okay. So the first thing is I note that I'm going to be using the law of sines for that. But the SSA situation I have to do some more analysis on. The next thing I want to do is I want to look at the size of that given angle. So my given angle is this angle P. Is that obtuse, right, or acute? Okay. That's acute. So now I need to compare my sides P and Q. So what's the relationship between P and Q? Well, P is smaller than Q, right? Everybody agree with that? So this is my bad situation where the side opposite my given angle is the smaller. So I'm stuck in this 0, 1, or 2 triangle situation. Everybody's following so far? So this is the hardest part right here, is figuring out what's going on. And after that, it's basically the same thing that we've done with the law of sines. This is the hard part. So the next thing I need to do to figure out which one it is, I'm going to do the longer side times sine of the given angle divided by the shorter side. And go type that into my calculator. And I get about 0.984. Now, since that was less than 1, it tells me I'm looking for 2 triangles. So I'm going to get 2 sets of answers here. In my experience, one of the things that cause problems for students is just like information management, is that you got a lot of information going on here that we want to make sure that we record. So I'm going to make sure that I'm clearly labeling things. So I'm going to make a space to record the answers for both triangles to start. And then I still need to find angle Q. So in triangle 1, I'm going to call that angle Q1. And in triangle 2, I'm going to call it angle Q2, because they're going to be different values. I need to find angle R. So again, I'm going to call that angle R1 and angle R2. And then side R, which I'm going to call R1 and R2. Everybody cool with the way I've labeled things? And we're cool with the way that we've organized this? Makes sense to organize it in such a way here that we want to keep things keep everything straight. Okay. Now I'm going to make a space for my work. And again, I'm going to make a space where I'm going to do all my triangle 1 work and a space for my triangle 2 work. One of the common mistakes I see students making on these problems is they just get confused at what information belongs with what triangle, and they use the wrong stuff in the wrong places. So I'm going to just try to be really careful about the way I'm kind of organizing my work, so I don't accidentally use a triangle 1 piece of information in triangle 2. Okay? So the way I typically like to do this is I like to start and I'll do all of triangle 1, and then I'm going to do all of triangle 2. I like to do it that way because it, again, reduces the chances of me getting information confused in one triangle from another triangle. It's not wrong if you wanted to jump back and forth, but I'd advise against it. So solving triangle 1, this is going to look just like any other law of sines problem. So I'm just going to go and start by finding the side and angle that we know both of, which is side P and angle P. And then I'm going to have to solve angle Q next because I know only side Q. Everybody good with that? So we'll just write sine P over P equals sine Q over Q. And again, I guess I mean Q1 really. So there's my law of sine set up. I'll then cross multiply. So 16 times sine Q1 equals 19 times sine 56. And then we'll divide both sides by 16. So I have sine of Q1 equals 19 sine 56 divided by 16. And then how do I get rid of the sine there out in front of Q1? What cancels that out? Do I divide by sine? No, sine's not a number. It's like an operation. It'd be like trying to divide by plus sign. That makes no sense. Landon? Yeah, we use sine inverse. Very good. So I do sine inverse to both sides. So the sine and sine inverse cancel out on the left. So I have sine inverse of 19 times sine 56 over 16. So I'll go to my calculator. So I'll do sine inverse. And you notice I've been using the fraction command to type all this stuff in. I typically like to do that on these problems because I don't have to worry about screwing up the parentheses too bad if I just type it in the way it looks like on my sheet of paper. Since you're dealing with potentially fractions, it can get a little bit messy there. So I get 7989. So let me go back and record that. Now I'm going to solve R1, and this is really easy because now I have 2 of the 3 angles. So I can just do 180 minus 56 minus 7989. Everybody okay with what I did there? So that gives me 4411. So let's record that. And now that I know angle R, I can use the law of sines to solve for side R. So again, I'll do sine P over P equals sine R1 over R1. And we'll again cross multiply and solve this just like we have all the other ones. So far, other than having to use the sine inverse, this hasn't been really any different than any of the other problems that we've done so far, right? Still kind of the same thing, just using the law of sines to kind of bulldoze my way through this stuff. Oops. And you'll notice I've been using the ands command a lot to just recall the whole thing I've written in there so I don't have to worry about typing a bunch of decimals and typing something down wrong. So I get 1343. And that finishes up triangle 1 for me. I'll go back down there. I'm sure people are still writing down the work. So triangle 2, it's actually going to be less work than triangle 1 was, which is nice. We only need to use the law of sines once in triangle 2 as opposed to twice. We had to use the law of sines in triangle 1. Well, that's good, right? That's a little bit less work. But Mr. Kulik, I don't even understand like how I'm going to get into that. Like, what am I doing differently to get the stuff in triangle 2 than in triangle 1? Right? Seems unclear. Here's the trick. This first angle we found in triangle 2, it's always just going to be the supplement of the angle we found in triangle 1. Oh, okay. Well, that's a lot easier than having to use the law of sines to find that angle Q2. I just take my answer from triangle 1 and I subtract 180. Can I do the same thing for R2? Heck no, you can't. Because there can only be 180 degrees in our triangle. But since I know angle P and I know angle Q2, it's really easy to get angle R2. Everybody okay with that? And now to find side R2, now I have to use the law of sines again. But this is the only time I'm going to need to have to use the law of sines to or during triangle 2. So we'll cross multiply. Oh boy. And then we'll divide by sine 56. And it's calculator time. And you'll notice that I don't have, since I just used my rounded answers or whatever, and did the stuff, the arithmetic in my head, I don't have 2389 to write the ants of. So I just had to type it in this time. So I get 782. Okay, so let's go record all that back up here. Okay, and I'll go back down because I'm sure some people are still writing the work there that I had. So, about this SSA situation when it comes to test time, we'll do another example of this because Lord knows I don't expect you guys to have that sing at once. But come test time or quiz time or whatever, I wouldn't expect you guys to do this, something like this in the example all the way through. So I would break this kind of a problem up into like two different kinds of problems. I would either ask you to determine whether there should be 0, 1, or 2 triangles, or I would say this problem has 2 triangles, solve for both of them. I wouldn't ask you to solve a triangle that had 2 answers to it, as I think that's a lot at this level. So you'll see problems where I ask you to figure out whether there's 0, 1, or 2 triangles, which is just, you know, the part right here. Or there'll be a part where I tell you there's 2 triangles and I ask you to do the part that's below. I wouldn't ask you to do both pieces at the same time, because if you mess that up, the first part, the second part's going to be gonzo, right? If you say there's 1 triangle or something, then you automatically are going to miss all those points. There's no way of avoiding that. So it's kind of an unfair way, I think, at this level to structure a problem. Does that make sense to you guys? Okay. Yes, go ahead. Let's look at another example here. Let's say that we have, I want that to be angle A is 74, side A is 2.5, and side C is 4.9. So we'll draw and label our triangle. So I know I have a side A and a side C, so I need angle C, and why wouldn't I name my third angle B? Because, well, the alphabet. So A, B, C, 74 degrees, 4.9 units, 2.5 units. Okay, what situation are we in? This is side-side angle, right? So we know we're going to be using the law of sines. But the side-side angle, there's more analysis I have to do before I start my law of sines, right? So the given angle is acute, right, or obtuse. Okay, it's acute. Okay, so then we need to compare that side that's opposite the given angle and the other side that we're given. So what is it? Is A less than C, equal to C, or greater than C? A is less than C, right? Everybody cool with how we did that? Okay, again, since the side opposite the given angle is the smaller one, that's the 0, 1, or 2 triangle situation. Ugh. Okay, so to figure that out, we're going to do the longer side times sine of my given angle divided by the opposite side, or the smaller side. So let's go type this into our calculator. See what we get. I get 1.88. Oh! Well, that's cool. That's bigger than 1. And I know in that situation, there's 0 triangles. So there's nothing to do. I can't solve for a triangle that doesn't exist. I'm done. Cool. That wasn't bad then. What do you guys think? All right. Let's do another example. I think we're on C now. Okay. Well, let's draw our picture. I think at this point it's pretty obvious that should be the label should be A, B, and C. Name our sides using our naming convention we've been using. Okay. What situation is this? This is side angle side. What does that tell me? Going to be using the law of cosines here. First time we're using this. So using the law of cosines in the side angle side situation, the first thing I'm going to have to solve for is the missing side length. So if I fill in the law of cosines, I have a squared equals b squared plus c squared minus 2 times b times c times cosine angle A. Okay, to get side A by itself, right now I have a squared. What do I need to do? Right now I have a squared. I want to get a. What do I have to do? Square root, right? Do I have to worry about the plus or minus? No, because we're talking about a side length of a triangle, so we know it has to be a positive number. There's no plus or minus. The minus is obviously a bunch of nonsense, gobbledygook, and my pen just stopped working for some reason. Oh my goodness, come on, pen. Did your guys' stylus ever just stop working mid-right? My hack is I just like unscrew and take the battery off. Oh my goodness, what did that just do? And then hope that, I don't know why my OneNote just did that. That was weird. And as much as you might be tempted to like get a number there, I would just type in my calculator just as is. I don't want to mess up the order of operations, and I know that my calculator doesn't mess up order of operations if I type it in exactly like it looks like on my sheet of paper. So rather than trying to do any intermediate calculation, I wouldn't. I'm just going to do type it in exactly like it looks like under the square root. And I get 951. Feels okay? Okay. Now I need to find either angle B or angle C. To do that, I would use the law of sines to do that. because, well, it's an easier formula than the law of cosines. The law of cosines has a lot going on. It's a much longer formula. The question becomes, does it matter which one I find first, angle B or angle C? Well, it only matters if you want to make your life easier. I don't know about you, but I'm not into making my life harder. My life's hard enough. So what we want to make sure that we avoid here in choosing angle B or angle C is to run into one of these SSA cases where there's an ambiguous case and we might end up with two triangles accidentally. Right? Everybody's okay with this? The way we avoid that is we solve for the smaller of the two angles. But Mr. Kulik, I don't know angle B or angle C. How can I tell which one is smaller? Look at the sides opposite the angles. Right? The side opposite angle B is 14. The side opposite angle C is 17. So which angle is smaller? B, because the side opposite angle B is smaller. So let's make a little note of what we're doing here. Okay, so we're just going to say at this step, after we've used the law of cosines, we're going to use the law of sines to solve for the smaller angle. Always. Okay? So now that we know side A, we can use sine of angle A over side A equals sine of angle B over side B. I can cross multiply and then divide both sides by 951. And then how do I get rid of the sine again on front of that angle B? Sine inverse. Very good. So 55/44. And then to find angle C, that's really easy because we know angle A and we know angle B. So 90/56. You feel okay on that? Okay. One more example for today, and then that'll close us out for the day. Sound good to you guys? I'm pretty excited. Okay, so what about the triangle with sides P equals 5, Q equals 8, and R equals 10? Well, go ahead and draw my picture. What situation do we have here? clearly side, 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 right? This is the one that no one should ever mess up ever, since there's no angles involved. Okay. Now remember, side, side, side had, we put a little asterisk on this last time because there was something else that we had to worry about here. And the thing that we have to worry about here in a side, side, side situation is this triangle even possible? For example, if I said, oh, what about a triangle with side lengths 1, 1, and 100? If you try to picture that in your mind's eye, you're like, ain't no way I can make a triangle with side lengths 1, 1, and then 100. That other side is way too long for me to actually be able to connect everything together, right? Does anybody remember from geometry how we check that? No, that's okay. It's that the sum of the legs has to be greater than the hypotenuse. But Mr. Kulik, how do I know which side is the hypotenuse? Dude, it's the longest one. So, 8 plus 5 is 13. That is indeed bigger than 10. So we're good. We got ourselves a triangle. But we need to make sure we do that at the first step, because I promise you, you'll run into a situation on occasion where we give you something like, 8, 5, and 15, where there's no triangle possible in that case, right? Now, looking at those three numbers, it's unlikely you'd be like, well, common sense is going to tell me, like 1, 1, 100, that one maybe you could tell, like, ain't no way you can make a triangle out of that. 8, 5, and 15, it's like, I don't know. Those aren't that big of it. But that's the check. Leg plus leg has to be greater than hypotenuse. Note it is a strict greater than, right? If you had 8, 5, and 13, still no triangle possible there. Okay? All right. Okay, so now it comes down to which angle do I want to solve for first, right? I have P, Q, and R. I know all three sides, so I can solve any one of them. Does it matter? Well, only if you don't want your life to get difficult. So in the law of sines, we found the smallest angle first. Using the law of cosines, we want to find the biggest angle first. So we're going to solve for angle R first. Again, I'll make a note of that, what we did. Okay, so I have R squared is equal to P squared plus Q squared minus 2PQ times cosine angle R. So in this problem, the most common mistake I see students make is they combine all of these things together right here. What's wrong with doing that? Well, the 2 times 5 times 8 is attached to the variable, right? That's attached to the cosine R. I cannot combine that with the 5 squared and the 8 squared. Those are not like terms, are they? No. So in general here, what I would encourage you to do, I wouldn't do any simplification. I would just rearrange this to get the angle R by itself. So I would just start by subtracting 5 squared from both sides, and then subtracting 8 squared from both sides. And then how do I move the negative 2 times 5 times 8 over? What's it doing to the cosine R? It's being multiplied, right? So to move that over, we have to divide. So divide both sides by the -2 times 5 times 8. So far, so good. How am I going to get rid of that cosine there? Cosine inverse. Very good. Oops, I meant 5 squared, obviously. Okay. So here, if you hadn't been using the fraction commands before, boy, howdy, do you want to do it on this one? Because this would be a lot of parentheses to make sure the calculator did this in the right order for you. However, if I use the fraction command, I don't have to worry a bit about all the stupid parentheses. I can just type this into my calculator the way it looks on my sheet of paper, and my calculator will sort it out for me if I remember to type in the 2 there, which it looks like I forgot. So I have 97.90 there. Everybody happy? Now, I'm going to use the law of sines to find either angle P or angle Q. Which one do I want to find? The smaller one, right? Just like before. Remember, again, we're going to use, whenever we use the law of sines, we're going to find the smaller angle. Law of cosines will find the bigger angle. So that's P. So I'm going to write sine of R, well, angle R, over R is equal to sine of P over P. And then we'll cross multiply. 10 times sine P equals 5 times sine 97.90. Divide both sides by 10. And then do sine inverse to both sides. So I get 2969. And then my last angle, then angle Q. That's easy because I know the other two angles. I can just add those together and subtract from 180. That gives me 5241. So that feels like where to stop here. Overall, the actual algebra, the solving of these triangles, not terribly difficult, right? We're just using the same two formulas over and over again. The tough part is figuring out what to do when, right? At this point, you guys should be able to do 1 through 22 in the problem set. I want to point out to you that we've covered 3 sections now of this chapter 7. There's only 4 sections total. I would say that next time we're going to do either 7-4 and then take the homework quiz, or on Wednesday we'll do the review and the homework quiz. The homework quiz will be either Wednesday or Friday this week. And then we can expect then the first day of class next week to be the Chapter 7 test. It's a fairly short chapter. There's only 30 problems in the problem set. The review's already up in the OneNote. So my suggestion to you is to get going on some of these problems before Wednesday, so that if the homework quiz falls on Wednesday, you're not going, oh, fiddlesticks. I haven't done any of this yet. I'm in a lot of trouble now. But you have at least a good idea that it's either, Wednesday or Friday that it's coming. Everybody feel okay on what the plan is? All those dates are up in My Notre Dame. I've made the assignments for everything except for the homework quiz, which won't post until the day it's showing up. You know what I mean? Because it's supposed to be a surprise, even though I'm giving you a kind of a heads up of when that might be. Okie dokie? Everybody cool? Jack, I'm going to sign off here as we're done.